Hello everyone, my name is Zeytuncu. I will record this presentation for CS7642 reinforcement learning. This is project number 1. And the project topic is traffic light control via planning and reinforcement learning. Like in any reinforcement learning problem, I will start with this environment and talk about our methods and results. Here's the problem setup. This is a classical Markov decision process. We have state space, action space. I'll talk about dynamics and reward. But in the simplest terms, we are trying to control a traffic signal where there are two perpendicular roads, south northbound and east westbound, vertical and horizontal. There are cars coming in with respect to a Poisson distribution. We have two traffic lights, but actually they are connected, so single control. If one direction is red, then the other direction is green. So in that sense, our agent is trying to learn to minimize the wait time and the queue length in each total direction. So our state space is simple. Each state is number of cars on the vertical direction and number of cars on the horizontal direction and the state of the light. And as I said, there's only one parameter there, so it's either 0 or 1, because if perpendicular is green, then the horizontal is red, and vice versa. The action is very simple. You can either turn or on and off the switch. Dynamics, as I said, the cars arrive with Poisson distribution. We are trying to minimize the wait time and bound the number of cars waiting at a red light in each direction. So for that sense, our reward function is negative of the number of cars in the vertical direction and number of cars in the horizontal direction. We are trying to get as close as to 0 possible here. So our methods are coming two different categories, model-based and model-free. Model-based are classical value iteration and policy iteration, and we need this to make sure we have a nice working environment to validate the correctness of the environment. But then we switch to model-free learning, where we have two models, Q-learning, which is an off-policy method, and SARSA, which is an on-policy method. Then we evaluated the performance of these methods. All right, so between Q-learning, once we established that value iteration and policy iteration justifies the correctness of the environment, when we switch to Q-learning and SARSA, I put them on two different slides. So SARSA is here, and if you compare to Q-learning, Q-learning improved slightly better than SARSA, and it definitely improves return time and congestion over training. It does converge to a stable policy, and it does it a little bit faster, and it goes lower than SARSA policy, so the queue is shorter. SARSA also improves performance, but it shows higher variance than Q-learning, and their on policy updates are a little bit more conservative. So in addition to um, value iteration, policy iteration in the standard setting and model-free learning, we looked at the model-free learning approaches in imbalanced traffic, where the vertical and horizontal direction have different thresholds. And in those cases, we compared value iteration, policy iteration, Q-learning, and SARSA. So here they are shown in different colors. And I'll start with a balanced traffic case where average total queue, as you can see, they are very comparable in the balance case, and they are very comparable in imbalance case too. When we look at the number of violations here, balance and imbalance case, you can see green is Q-learning, and it almost does not appear. That means it is not violating at all, which means it is good performance. SARSA violations are more, and you can see it is especially more in imbalanced traffic compared to balanced traffic. And when we look at value iteration and policy iteration, they are overall consistent, and value iteration performs better here, as you can see, in imbalanced traffic. In the balance case, they performance between value iteration and policy iteration is comparable. All right, so main takeaways. value iteration and policy iteration agree. So we do have a convergence situation here, which is very good. So our MDP was working well. Our learning policies, Q-learning and SARSA, they performed well. Q-learning was a little bit more robust, especially in imbalanced traffic, but SARSA still showed performance improvements with a little bit more high variance, especially when the traffic in both directions are asymmetric. I really enjoyed working on project. I hope this presentation was helpful.